Alright, so I thought I'd consider Bertrand's paradox with respect to commutativity, because the fundamental problem appears to be a result of the parts of the problem not being commutative. Right? It's a non-commutative problem, and that's why you get different results. So the thing that I was trying to say all along, and everybody's like, "Oh, you don't understand," is the true solution. It has a reference frame which takes both the triangle and the circle into account. The other false solutions they start with a reference frame that only takes the circle into account. So you then have to do further processing, and now you are changing reference frames. So now the thing is non-commutative. So that's why you're getting different results. Okay, so the true solution, the reference frame is the radius of the circle being used as a perpendicular bisector of the triangle side. So we're taking a fundamental component of the circle, a fundamental component of the triangle, the thing we're talking about, right? So Bertrand's paradox, the question that we're asking is, what are the odds of finding, what's the probability of finding a random chord in the circle whose side length is longer than or shorter than, it doesn't matter either way, the side length of an equilateral triangle that is inscribed within the circle. Okay. So this true solution is the only one whose reference frame involves both a fundamental component of the circle and a fundamental component of the triangle, specifically the part of the triangle that we're interested in. Okay. The output of this is a distance along the reference frame, a distance along that radius where the side intersects, where the triangle side intersects the radius. Okay. And once you do this, there's no further processing. You're done. That's it. Okay, so we operate within our reference frame, get a solution, that's it. And the result is 1/2. Now, you have the false solutions, and there's actually two classical ones. This last one here is one that I discovered about a year ago. And still people will be like, "Oh, you don't understand," even though I'm able to look at the problem and be like, "Oh, wait, there's one you missed." To a problem that's people have looked at for generations and nobody noticed that there was another one. Like, are you fucking kidding me? You think I don't understand what I'm talking about? Okay, so this is why we're going into this. Alright, false solutions. 1. So here your reference frame is the area of the full circle. It has nothing to do with the triangle whatsoever. Okay? Now, then when we're processing this, the output is going to be the area of the circle tangent to the triangle's side. Again, that's not actually part of the triangle at all, right? You're comparing the areas of two circles. There's no further processing after this to correct the fact that we did this wrong. So the result is 1/4. Right? If you're familiar with, well, anything, you can see why this is stupid. Lots of people told me that I was mistaken for not considering this one. Are you serious? The reference frame doesn't even involve the triangle, and the processing of the reference frame doesn't even involve the triangle. In both cases, we're looking at circles. Alright, now, the next two, there is further processing. So there is further, basically we change the reference frame. So now for these other two, it becomes a problem of commutativity. For for this one, this first false solution, it's false because it's just fucking stupid. It's like, you're not comparing a triangle and a circle, you're comparing two fucking circles. You goddamn idiots. Are you actually this stupid? Anyway. Yeah. Jesus. So the second one, this is the last classical solution presented by Bertrand, and the last one that anybody else before me found, apparently. So your reference frame is the circumference of the circle, and the output ends up being an arc of random length. So again, this has nothing to do with the triangle, right? So we need to do further processing, and what we need to do is we need to find the chord corresponding to that arc, and then compare that arc to the triangle side. So we end up having 3 reference frames. There's the initial reference frame of the circumference of the circle. There's the further processing where we find a chord corresponding to the arc produced by on that circumference of the circle. And then we have a third reference frame change where we compare the chord to the triangle side. The result of this is 1/3. Okay? This is fucking nonsense. You're going all over the goddamn place, doing all kinds of crazy shit, and your results doesn't work. Like, when you run the experiment and plot it out, it's obviously not working. The center of the circle is sparse compared to everywhere else. So, what the fuck are you doing? And then 3. So this is the one that I found after I just glanced at the problem and it was like, wait, you're not understanding what the question even is. Oh, look, there's another solution. Yeah, so here your reference frame is a line intersecting the circumference. Okay, so you have an intersection point. And basically what you can do is you can pivot on that point, and what we're selecting for is random lengths of the chord. Okay? So, there's still further processing after this. We need to take that random chord length, we need to take that and compare it to the triangle. So we still end up with a reference frame change. And the result for this is 1 minus square root of 3 on 2. Okay. So of these, there's only one solution whose reference frame in the first place involves the circle and the triangle. There's only one of them that starts off looking at things in the right way. Okay. The other ones, one of them just doesn't really ever involve the triangle at all. And that is one of the most favored ones. One of the ones that people are like, yeah, this makes the most sense. This is my point. That the people doing math are actually mostly just dumb and don't have any clue what the hell they're talking about. Or, like, their literacy skills are just abysmal. They read the question and then they come out with a solution that has nothing to do with what the question was asking. Right? The question is asking about the correlation between chords of the circle and the triangle. So you need to set up a problem in a way where your initial reference frame deals with both of those. But favored solutions end up being the ones where that's not what's happening. Are you kidding me?